In this video, we'll talk about section 3.2, a little bit more about functions. In this case, we're going to talk about the domain and the range. So our definition, for a given function, the complete set of possible values of the independent variable is called the domain of the function. So remember, the independent variable, if you want to think of our usual x and y axis, is usually the x. The complete set of all resulting values of the dependent variable is called the range of the function. So these are the outputs. We usually think of these in terms of y. As noted earlier, we will use only real numbers when working with functions. This means there may be restrictions as to the values that can be used, since values that lead to division by zero or to imaginary numbers may not be included in the domain or range. Here's what this means. If you take a fraction, you can't have a zero on the bottom. It's an undefined. You can't take anything and divide it into zero. The other thing that is not a real number is if you take the square root of a negative, there is not a real number that if you multiply it by itself, you get a -4. So that's what it means where there might be restrictions. Okay, so let's take a look and see what this means. So the first example is find the domain and range of f of x equals 2x minus 1. So we want to know the domain are all the values for x, the inputs that we can put into this function and get an output. So when you think about restrictions, can we put all the negatives in there? Yep, we can take 2 times any negative. Can we put 0? Yes. Can we substitute positive numbers? Yes. So this means we're not limited on any x value real number that we can put in there. So the domain is all real numbers. A way that you can express that in interval notation is everything from -infinity to infinity, or all real numbers is a capital R with 2 marks on it. So that means all real numbers. The range are the set of outputs. So when we put any x value we want to in here, does our output also result in all real numbers? And then think about this a little bit different way. What is the graph of this function? This is the graph of a straight line. It has a y-intercept of -1 and a slope of 2. So if I graph that line, and you think about choosing values along the x-axis, is there an x value, an x-coordinate everywhere along the graph? Yes, so all real numbers. Is that the same for y? So if I put in a 1 for x, I end up with a 1 for y. If I put in a 2 for x, I end up with a 3 for y. So if you look up and down the y-axis, yep, there's a y value for every value. So the range is also all real numbers. Okay, so linear functions, domain and range, are always all real numbers. If it's not a vertical or a horizontal line. Number 2, find the domain and range of this function in terms of z. F of z is equal to z squared plus 2. So then we think of the inputs. Can we put anything we want to in for z? Can I put positive numbers in here? Yes. You can square positives, you can square negatives, and you can square 0. So the domain of this function is all reals. But the range, we don't always get everything, all real numbers as an output, because whatever you put in here for x, if you put a negative value in here, so let's say x is 0, then I get 2. If x is -1, that -1 squares becomes positive and I get 3. So if I put a negative number in there, I'm not going to end up with a negative value. I'm going to end up with a positive value. Let's see. So I can't have any negative numbers. It would help to graph that. I'm going to graph it on a graphing calculator. It's actually the graph of a parabola. I don't need the calculator. what the graph of that looks like is a parabola moved up 2 spaces. So this is the graph itself. So you can see as you pick x values, any x value, it will hit the graph somewhere and it will have an x coordinate. But it won't for all the y values. When y is 0, it can't be 0 because there is no x, there's no way that you can get a value of 0 for y. Notice our graph starts up here at 2, and you look along the y-axis, that's the smallest value. So the range, the y values, or the f of z values, are all going to be greater than or equal to 2. Interval notation, that includes 2 to infinity. Okay? So domain and range, domain is sometimes a little bit easier to figure out, range is a little tougher. And looking at the graph can help. Next example, find the domain of f of n is equal to n plus 1 over n minus 3. So in this example, notice that you've got in the denominator n minus 3. We know that the denominator can't equal 0, so figure out what would n have to be to make that 0. So if we set the denominator equal to 0, we see that if n equals 3, we get a 0 in the denominator. That can't happen. So the domain this time can be any number, any real number, except n cannot equal 3. Because if n was 3, it would make that an undefined. Okay? Interval notation, if you need to use that at any time, that's negative infinity to 3, along with 3 to infinity. Okay? Or you can just write any real number, n cannot equal 3. So when you look at functions as equations, we take a look and we kind of reason through what can you put in for x, or the independent variable as your domain. What are your outputs going to be as your dependent variable or your range? When you have an application problem, such as this one, this is function that actually represents a real situation. The height h in meters of a certain projectile as a function of time t in seconds is h equals 20t minus 4.9t squared. So the domain of this function, even though we could substitute negative values, 0, and positive values for t and get an answer for h, negative values of time have no meaning in this case because it's a real application. This is generally true in applications. Therefore, the domain is t is greater than or equal to 0. And I just wanted to note that in real life, the domain is restricted about what can physically happen. So also, because we know the projectile will not continue in flight indefinitely, there is some upper limit of the value of t. And if we were to talk about the range, the height, a projectile does something like this. So even though the equation itself, graph might look like that, these values don't make sense because it's a real life application problem.